Okay, we've made it. This is the final video on the rules for exponents. And the only thing we're going to do in this video is take a look at problems, examples, where we have just different combinations of all the different rules mixed together in the same problem. So this video will just be a series. I think I've got 3 questions here planned for us that we'll work through and just kind of talk about how to process these when we've got lots of different parts flying around. So with that said, let's go ahead and get started. Only one learning objective for this video. And that learning objective just simply is to simplify expressions using all of the various different rules. So with that said, here's our first example. In this first example, we're going to have a set of variables, and we're going to raise those variables to the -2 power. Okay, so there's our first example. All right, now, one thing that I would strongly recommend as we get started here, I would recommend, if we were doing this in class, if we were face-to-face in a traditional classroom, the way we would do this is I would write this problem up on the chalkboard. We've already done examples of every rule individually in the previous videos, and we've also done a handful of examples in the previous videos where we mix the rules together. So there's a very real sense in which we've done this already. Obviously, we haven't done this problem, but what we're about to do, we've done things like this. So what I'm trying to get to, the point I'm trying to make, is that I would recommend for all 3 of the example problems that we're getting ready to do here in just a minute, I would recommend that once I write the problem on the screen for you to see it, that you pause the video and try it on your own first. That's what we would be doing in class right now. If this was an actual in the classroom scenario, I would have written this problem up on the chalkboard, and then I would have turned you loose as a class to take a couple minutes and try it. So why don't you do that right now? Pause this video, take a minute to see if you can get to an answer, and then restart the video and compare what I do to what you did. All right? All right, so hopefully you've tried this already. But if not, that's okay. Let's give it a shot anyway. You know, we've already discussed in our class, even though we're still at the very beginning of our class, we've already discussed the fact that almost every single problem, perhaps every problem, can be done correctly in multiple different ways. And this one is no different. And so I'm just going to explore 2 different ways that you might do this that are both correct and acceptable. When I'm done, I'll share with you the one that I personally prefer, but by no means should you feel like you have to do it the way that I do it. Okay? The first thing that you might recognize is I have something with a multiply inside of it and an exponent on the outside of it. And based on what we've learned most recently, you might look at that and think to yourself, hey, this is a great opportunity to use the distributive property for exponents. And you're 100% right. This is a spot where I could use the distributive property for exponents. So method number 1 that I'm going to try is to use the distributive property first. A lot of students like to start there again because it reminds them of the distributive property they already know. And so it's a nice, convenient, easy place to start that connects back to stuff that we've learned previously. So if you do that, then you're going to get a p squared raised to the -2, and you're going to get a q cubed raised to the -2. Okay, so that's one potential first step. Now, like I said, there's many other potential first steps. I'm going to only explore one other one. But before I explore that other one, let's try and finish this one. Let's get this one down. Okay, so if you did not do that first, that's okay. Hold on for a second. We're going to look at another method in just a minute. Okay, but then when you get here, again, you have choices to make. You have options to do. What I think probably many students would do is they would look at this and say, this is a power to a power scenario. So again, you could do this different ways. I'm going to use the power to the power option. And if I do that, then the power to the power rule tells me I need to multiply these together. So I've got a +2 times a -2. That's going to give me p to the -4 power. And I have a q to the 3rd power raised to the -2. So I'm going to multiply 3 times -2. That's going to give me q to the -6 power. So that's a potential second step. Again, there's a lot of options here. You might not have done it that way, but this is a potential second step. Now, one thing that perhaps I haven't emphasized enough in the previous videos, and so let me take a second right now to emphasize it. when we simplify exponential expressions, there should be a couple things that are true about our answers. So when we are all done simplifying, some things that should be true about our answers. Well, just like normal simplification process, when we're all done simplifying, the parentheses should be gone, like terms should be combined together. So if there's an X in the top and an X in the bottom, I'm not done yet. I need to get those things taken care of. So I'm just going to list that as like all our normal stuff, right? So normal simplifying stuff. Get rid of parentheses, combine together anything that can be combined, et cetera, et cetera. So all that normal stuff still applies. But in exponents, there are a couple other things that are particularly important. Particularly important rules for exponents are all of our exponents should be positive. Positive exponents only, okay? So that's an affirming way to write that rule. We're focusing on the positive result, only positive exponents. That's what you should have. If I want to write that same rule and write it in sort of a negative tone, what you could say is that you're not allowed to have negative exponents or zero exponents. Okay, you can't have a zero for an exponent, you can't have a negative for an exponent. So that rule right there is telling me I am not done yet right here, because all of my exponents are still negative. So I need to go one step farther, and I need to use my negative exponent rule. And negative exponent rule tells me that these things make reciprocals. So if I want to think of this as being a p over 1, then this negative exponent is going to flip that thing upside down. In other words, it's going to send the p down to the bottom of the fraction. And when it goes down there, I've used up the negative as it moves. Think of this as like gas in the tank. The gas is all used up. Once I move it from here to here, I've driven my distance, I've used up my gas. So now I've got a positive 4 instead of a negative, okay? And then the 1 goes up to the top. Same thing is going to happen with the q. Anything, 1 times 1 just equals 1. So I'm just going to make this one big fraction with a 1 in the top, move the q down here, it becomes positive, and there's my final answer. So this is one method that you might use to solve this problem, where I have taken the different rules as far as distributing and power to a power, and I've used that method. Okay, now there's another method that you can use. And again, the reason why there's lots of different methods is because all of these things technically are the same step in the order of operations. All of these are the exponent step. And so technically I can do all these things in a different order. So in this problem, I dealt with the negative sign last. In this method, I'm going to deal with the negative sign first. So the very first thing I'm going to do right at the get-go, right at the beginning, is I'm going to say I've got something, and that something has a negative exponent. So the very first thing I'm going to do is I'm going to flip that something upside down. And some students prefer to do that because that gets rid of the negative sign, and the negative sign can really creep people out. Some people don't like negative signs. And so this is an option. Now my negative sign right from the get-go is gone. I use that negative to flip my thing upside down. When I do that, the negative is gone. And now from here, it's very similar to what I did here. And so I'm going to do this a little bit faster instead of breaking it down into lots of individual steps. We've already talked about the distributive rule, and we've talked about the power to the power rule. So I'm just going to do both of those at the same time right now. When I distribute it to the p squared, the power to the power rule will make me multiply my exponents together. So I'm going to get p to the 4th. And when I distribute it to the q cubed, the power to the power rule will make me multiply those together. So I'm going to get q to the 6th. And sure enough, I have the same answer, which means it doesn't matter which way I do it, I get the same answer both ways. Okay, so 100% up to you which way you do this. And as I indicated along the way here, there's actually other ways that you could have gone too. There's many ways you could do this, but no matter which technique you get, this is the answer you should end up with. Okay, now I did tell you that I would share with you the method that I personally prefer, not that you have to do it, but I do know that I have some students who they like to know what their teacher prefers, because they figure, hey, my teacher has 15, 20 years worth of experience. Their opinion in this situation might have some value to it. So my opinion, not that it's right, there are other people who will disagree with me, but my opinion is I prefer to get rid of negative exponents first. I'm in that camp of people that I don't like to work with negatives if I don't have to. And so I want to get rid of the negative as soon as possible, get it out of there. And then I'm just dealing with all positive things from that point on. Okay, so I guess you could describe me mathematically as a peaches and cream kind of guy. I just want everything to be happy and positive and yay. And so getting rid of that negative makes everything positive as I move forward. Okay, so there we go. There's our first example. Let's move on to a second example, example number 2. And again, once I get this written here for you, I would recommend that you pause the video and try this on your own first before you watch my answer. So here we go. I have 3 times c cubed d e to the 0. And that is divided by 9 times c d to the negative 1 power. Okay, so here's our next example. Why don't you pause the video and give that a try on your own? All right, so hopefully you've tried that. If not, well, you know, I can't know either way right now. That's the, I guess, your advantage with YouTube. I don't know what you're doing, but I would recommend you try this first. But here we go. We did a problem like this in a couple of videos ago. And in this type of problem, what I personally recommend is I recommend pairing things up based on the type of stuff that I'm working with. So I've got a 3 and a 9, which are just regular old numbers. And then I've got some C's. And then I've got some D's. And last but not least, I've got this E. And so that's the way that I would approach this problem, is I would take care of each of those individually by itself first. So first, how do I deal with a 3 over 9? Well, notice neither one of them have any exponents. So none of my exponent rules matter. I don't need to do anything as far as exponent rules are concerned. I just simply need to simplify the fraction 3 over 9. And both of those are divisible by 3. If I divide 3 by 3, I get a 1. And if I divide 9 by 3, I get a 3. And so when I deal with that first piece, that's what I'm left with, is a 1 over 3. Okay, so there's my first piece. From my second piece here, I've got a c to the 3rd over c. And remember, this c, even though I don't see an exponent on it, there's this sneaky hidden ninja 1, because I obviously have 1 c right there, right? This means I have 3 c's getting multiplied together. This means I have 1 c, and if there's only 1, it can't multiply. But there we go, I've got it, all right? So for this, I think I would use the quotient rule. 3 on the top, 1 on the bottom. I'm going to make a fraction where the small exponent was, I'm going to put a 1, and where the big exponent was, I'm going to subtract my exponents. And so when I simplify this, I'm going to just end up simply with a c squared in the top. For right now, I'm going to keep that 1, but that's what I'm going to end up with when I simplify that thing right there. Okay, moving on to the d's. There's a couple different ways you could do this. Some people would, again, do the quotient rule. I like the quotient rule in this case. This has a sneaky hidden ninja 1. A positive 1 is bigger than a negative 1, so I could do this exact same process with the correct numbers, and that would work. But for the sake of giving you options, I'm going to show you a different method. You can use the quotient rule if you want, go ahead. But I'm going to show a different method. The method that I'm going to show is deal with the negative exponent first. So negative exponents flip things. That's going to take this d, and it's going to move it up to the top when I flip it. So there's a d to the 1st power in the top, and then this one is going to move up there with it. And that's what I'm going to end up with, is d to the 1st times d to the 1st. And now I can use the product rule. Product rule says I have 2 things multiplied. They have the same base. Let's add the exponents together. So 1 plus 1 is going to give me a 2. And so I end up, when I simplify this thing, I'm going to end up with a d squared over 1. So that's another way that you could do this, okay? Now, some students might ask, where did this 1 come from? Okay, the reason I put that 1 there is simply because I know that the problem as a whole has all of these things inside of a fraction. And I know that I can take anything and put it over 1 to make a fraction. And I want to preserve the look of a fraction so that when I get all done, I've got all fractions and I can simplify at the end. And that's the reason why I put it over 1, is just so that I can see how my fraction works and not get confused there. I suppose there's a very real sense in which that 1 is optional. You don't necessarily need it. All right, now all that leaves then is the e to the 0 power. And we know that anything, well, almost anything to the 0 power, right? There is one exception. What's the one exception? 0, right? 0 to the 0 power is undefined. But anything else to the 0 power always equals 1. And so that e to the 0 power is going to be a 1. If I want to preserve the look of a fraction, I can always make it into a 1 over 1. That's optional. You don't have to do that. But that's what I get there. So now I take my 3 parts and I put them together. I've got that 1/3. I've got this c squared over 1, a d squared over 1, and then a 1 over 1. And when I put all of this together in the top, 1 times c squared times d squared times 1, these have different bases, so I cannot combine them. I'm just going to simply end up with a c squared times d squared, right? Because when you multiply by 1, it doesn't change anything. It's like the ones kind of just disappear, all right? In the bottom, 3 times 1 equals 3, 3 times 1 equals 3, 3 times 1 equals 3. So that whole bottom just becomes a 3. And there is my final answer, okay? Now, one other just word real quick, because I know early in the school year, I often get lots of questions about students like, how much work do I have to show? Do I need to show all of this right here? And the answer is no, you don't. When you have a sufficient amount of practice, it's very possible that you might feel comfortable going straight from this all the way to the answer in just one step. That's a possibility. And if you reach that point where you're comfortable doing that, I want to give you permission to do that. I am not one of those teachers that's like, you need to show every single little step. If this was a pre-algebra class or the beginning of a basic algebra class, I would want to see a lot more work from you because I'd want to make sure that I understand the way that you're thinking. But this is your second year of algebra. Hopefully you understand some of these basic sorts of things. And if you can do that in your head, I want to give you permission to do that. All right, so I said 3 examples. We have one last example. Let's finish this video up by taking a look at this problem here. I have x squared times y to the minus 3 power over 3y squared, and then that fraction is multiplied by y squared over x to the minus 4 power. Oh, and this whole thing is squared. There we go. All right. So now on this problem, oh, like before, you should pause the video right now and you should give this a try on your own. And as a side note, if you try this on your own and you make a mistake right on the very first step, that's okay. When you restart the video and you see what my first step is, then you can pause the video again and correct your work and see if you get the right answer from that point forward. Okay, these are good ways to learn. Okay, so pausing the video and working as much as you can is an excellent way to learn. So make sure you do that right now. All right, so now that you've tried the problem, let's go ahead and do this. On this problem, order of operations become a little bit more important. And the reason they become more important is because I've got this great big thing here that is being multiplied by another great big thing here. And I also have an exponent applied to this great big thing here. And so because I have a multiply and an exponent both happening to this thing right here, order of operations becomes important because the exponent has to be dealt with before the multiply. All right. So I think that's where I'm going to start. I'm going to start with, let's deal with this exponent. So I've got an exponent. Inside of this, I've got a fraction. So that's a distributive property. I know I can send this to both the top and the bottom of my fraction. And when it gets into those two parts, once it gets in there, then that's a power to a power situation. So when I have a y squared being squared, then I multiply those two exponents together. 2 times 2 gives me 4. In the top of this fraction, I'm going to end up with a y to the 4th. Down here, I've got a negative 4 exponent. I'm going to distribute this 2. So negative 4 times 2, that's equal to negative 8. So in the bottom of the fraction, I'm going to end up with an x to the negative 8. And so now I've dealt with this exponent. I haven't done anything with this other stuff yet. So that other stuff is all still there. And now I'm at the point where I can start working. Okay, now again, lots of options here. There's a lot of different ways that you could do this. For the sake of time, because this video is already starting to get long, I am not going to do this 3 or 4 different ways, even though there are, I can easily just by quickly looking at it, I can think of 3 or 4 different ways you might go. Okay, so I'm just going to share with you the thing that I would do. The first thing I would do is I don't like having these parentheses here. And so the first thing I would do is I would multiply these 2 fractions together. I would multiply those 2 fractions together. So when I multiply those 2 fractions together, the rule for multiplying is that you just multiply straight across. And so basically what that does is it just creates one big fraction that has all of this stuff in it. Okay? So basically it's almost like I just removed the parentheses. That's what I would do first. Now you don't have to do that first. You could simplify this thing and then simplify this thing and multiply at the end. That would be fine. That would be okay. But in this case, this is what I would do. Okay? Now what I would do, kind of like we did on example number 2, what I would do is I would match up all the different things that are similar, and I would simplify each one of those things individually. So the first thing I see is I've got a 3 in the bottom. There's no other numbers anywhere else that are just plain numbers. I mean, I've got my exponents here, but there's no other just plain numbers. So there's nothing to combine with that 3 or cancel with that 3 or simplify with that 3. So I know in the end, I'm just going to have a 3 down in the bottom. That's just going to be there. Okay. Now, the next thing I see I have is an x squared in the top and an x to the negative 8 in the bottom. And so even though they don't line up, I know that with multiplication, things are allowed to move around. And so I could make them line up if I want to. That's not necessary. So I'm going to go in and simplify these 2 things. And I'm going to do that with the quotient rule. 2 is bigger than negative 8. So in the top of my fraction, I'm going to do an x squared minus a negative 8, right? So 2 minus negative 8. I've got to do a change with those signs. I'm going to end up with 10. And that x to the 10th is going to be in the top because that's where my bigger exponent was. So I've got x to the 10th. Okay. And now that leaves me with all of these y's right here. All of these y's. And again, you can approach that a couple different ways. The way that I'm going to approach it is with the product rule and the quotient rule. So the product rule says these 2 things, because they're being multiplied, I can add those exponents together. So I've got a negative 3 plus a 4. That's going to equal positive 1. Okay? Then that means now these 2 things together in the top, they've turned in a y to the 1st power. That's what they've become when I use my product rule. When I combine this with the y squared that's in the bottom, I'm going to use the quotient rule. The big exponent is down in the bottom. So I'm going to write my answer in the bottom. 2 minus 1 equals 1. So in the bottom of my fraction, I get a y to the 1. Okay. Now, normally I wouldn't bother to write that 1. I would just do the sneaky hidden ninja, and I would write it like that. And that's the way that I would write my answer. Sorry, that was cut off. There you go. I wouldn't bother to write the 1. I'd leave that 1 as a sneaky hidden ninja. And I would write it this way. If you write the 1 here, I certainly will not mark that wrong. That's okay to do. All right. Again, there is probably, I don't know, at least a dozen different ways, literally. I'm not trying to exaggerate here. I can think of lots of different ways that you might do this problem. This is the way that I personally would do it. All right. So thanks for watching this video. That is the last video on exponents. So make sure you get some good practice and then move on to take the quiz over exponents.